Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation using variation of parameters method. So let's get going. Problem: solve y double dash plus 4y equal to 4 secant square 2x or d square y by dx square plus 4y equal to 4 secant square 2x or d square plus 4 into y equal to 4 secant square 2x using the variation of parameters method. So we are given a differential equation of order 2. Given differential equation, y double dash plus 4y equal to 4 secant square 2x considered as equation number 1. We can write y double dash as d square y by dx square plus 4y equal to 4 secant square 2x and write d square y by dx square as capital D square y using the differential operator capital D. Now take y common from the two terms of LHS. We'll get d square plus 4 into y equal to 4 secant square 2x considered as equation 2. So the equation 1 and 2 in operator form is our equation 2, right? I mean the first equation and second equation in operator form is our equation 2, which is in operator form say f of d into y equal to some function of x, where f of d is d square plus 4 and r of x is 2 secant square, I think it's 4, right? 4 secant square 2x. Now we'll find the solution to our problem using, the general solutions given by y equal to yc plus yb. We'll find yc using the auxiliary equation. Later we'll find yp using yc. Now coming to the auxiliary equation. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of d square plus 4, right? Let's replace the differential operator d by m so that we'll get f of m equal to m square plus 4, and the auxiliary equation becomes m square plus 4 equals to 0. We need to find roots to this equation. So let's take plus 4 to RHS. We'll get m square equals to minus 4 and m equal to plus or minus square root of minus 4. We can write minus 4 as minus 1 into 4, and now split the square root as square root of minus 1 into square root of 4, since square root of minus 1 is I and square root of 4 is 2. So this gives us plus or minus I2. Therefore, m equal to plus or minus I2 is a pair of complex conjugate roots. The roots are complex conjugate. Okay, we know that when m equal to a plus or minus ib, a pair of complex conjugate roots, then yc or complementary function looks like e power ax into c1 cos bx plus c2 sin bx. In case of a is 0, we'll have e power 0 into x, which is e power 0 into c1 cos bx plus c2 sin bx. Since we know that e power 0 is 1, so we'll get 1 into c1 cos bx plus c2 sin bx, just c1 cos bx plus c2 sin bx, right? Let's now write our complementary function using this formula. Complementary function is given by y equal to, just compare plus or minus I2 with plus or minus IB, then for b equal to 2, we'll have yc equals to c1 cos 2x plus c2 sin 2x. Okay, therefore y is equals to c1 cos 2x plus c2 sin 2x. Now using this we'll write yp just by changing parameters with some functions of x. Let yp equal to change the parameters or constants with functions of x, a and b. We'll have a cos 2x plus b sin 2x, where a and b are functions of x. Now we can compare yc with c1u plus c2v or yp with au plus bv. Then you'll have b, u and v, where u is cos 2x and v is sin 2x. See? U is cos 2x and v is sin 2x. We'll find a and b using a is given by integral minus v into r of x by uv1 minus vu1, and b is given by integral u into r of x by uv1 minus vu1. If you notice, we are having uv1 minus vu1 in both the formulas, so we'll begin with uv1 minus v1 and later we'll find a, v, yp, and finally we'll put it in the general solution. Y equal to yc plus yp. Okay, now coming to uv1 minus v1. v1 is nothing but v dash and u1 is nothing but u dash. U is cos 2x into v sin 2x dash minus v into u dash. This gives us cos 2x into derivative of sin 2x with respect to x is 2 cos 2x minus sin 2x into derivative of cos 2x with respect to x is minus 2 sin 2x. This gives us 2 cos 2x into cos 2x is cos square 2x minus into minus plus 2 sin 2x into sin 2x is sin square 2x. Or we can write this as 2 sin square 2x plus 2 cos square 2x. Now take 2 common from these two terms, we'll get 2 times sin square 2x plus cos square 2x. Since we know that sin square theta plus cos square theta equal to 1, so we can replace sin square 2x plus cos square 2x with 1. We'll get 2 into 1 is 2. Therefore, uv1 minus v1 equal to 2. Now coming to a. A is given by integral minus v into r of x by uv1 minus v1 equals to minus v sin 2x into r of x 4 secant square 2x by uv1 minus v1 is 2. You'll get minus 2 integral secant square 2x sin 2x dx. We can write secant square 2x as secant 2x into secant 2x into sin 2x dx. Since we know that secant theta is reciprocal of cos theta, so we can replace 1 secant 2x with reciprocal of cos 2x, which gives us minus 2 integral secant 2x into reciprocal of cos 2x into sin 2x dx. This gives us minus 2 integral secant 2x into 1 by cos 2x into sin 2x is sin 2x by cos 2x, right, which is tan 2x. Since sin theta by cos theta is tan theta, which gives us minus 2 integral secant 2x tan 2x into dx. Since integral secant ax tan ax dx is 1 by a secant ax, so this becomes minus 2 into, just compare the integrand with secant ax tan ax, and for equal to 2 you'll have 1 by 2 secant 2x. 2 gets cancelled and you'll get a equal to minus secant 2x. Therefore a equal to minus secant 2x. Let's now find b. b is given by integral u into r of x by u v1 minus v1. U is cos 2x into r of x 4 secant square 2x by u v1 minus v1 2 into dx. This gives us 2 integral cos 2x into secant square 2x dx. We can write secant square 2x as secant 2x into cos 2. Sorry, secant 2x into secant 2x. Since we know that secant theta is reciprocal of cos theta, so we can replace 1 secant 2x with reciprocal of cos 2x. So you'll get 2 integral cos 2x into reciprocal of cos 2x into secant 2x dx, where cos 2x gets cancelled and this is equals to 2 secant integral secant 2x dx. Since we know that integral secant ax dx equal to log mod 1 by a log mod secant ax plus tan ax, then for a equal to 2 you'll have 2 into 1 by 2 into log mod secant 2x plus tan 2x, or you can write this as, just cancel 2, or you can write this as log of secant 2x plus tan 2x. Okay, therefore b equal to log of secant 2x plus tan 2x, right? We got a and b. Let's now find yp. Yp is given by a cos 2x plus b sin 2x. Substitute a and b here. Minus secant 2x into cos 2x plus b log of secant 2x plus tan 2x into sin 2x. This gives us minus secant 2x into cos 2x plus sin 2x into log of secant 2x plus tan 2x. Since we know that secant theta is reciprocal of cos theta, so we'll just replace cos 2x with reciprocal of, secant 2x with reciprocal of cos 2x. We'll get 1 by cos 2x into cos 2x plus sin 2x log of secant 2x plus tan 2x. Cos 2x gets cancelled and you'll get minus 1, that is yp equal to minus 1 plus sin 2x log of secant 2x plus tan 2x. We got yp and yc. Let's now write general solution using y equal to yc plus yp. Therefore, the general solution is given by y equal to yc plus yp. Then y equal to yc, c1 cos 2x plus c2 sin 2x plus yp is minus 1 plus sin 2x into log of secant 2x plus tan 2x. right? Therefore, y equal to c1 cos 2x plus c2 sin 2x minus 1 plus sin 2x into log of secant 2x plus tan 2x is the required general solution. So this is all for now. I hope you'll understand. We'll see you in the next video. Until then, bye bye.